Hello, listeners, and welcome back to Everyday Health Stories, the podcast where we explore the fascinating world of medical science through the power of storytelling. Today, we're diving deep into the really complex world of Alzheimer's disease and exploring a groundbreaking new molecule, DDL920, that has shown some really promising results in restoring cognitive function.
Absolutely, Anna. This is cutting-edge research, and it offers a glimmer of hope in a field that desperately needs it. We'll be discussing the science behind this molecule, the studies that have been conducted, and what it could potentially mean for the future of Alzheimer's treatment. So, yeah, exciting stuff.
Okay, so before we get into the specifics of this DDL920, can you tell us a little bit about brain oscillations? What are they and why are they so important in memory and all that good stuff?
Sure. So, brain oscillations, also known as brain waves, are rhythmic patterns of electrical activity in the brain. They're like the electrical hum of our brains, constantly fluctuating, and these oscillations occur at different frequencies measured in hertz. One type of these oscillations, called gamma oscillations, they're in the 30 to 120 hertz range. These are particularly important for higher level cognitive functions, things like memory, attention, and perception. Now, these gamma oscillations are generated by the synchronized activity of neurons, the brain cells, and this synchronization is absolutely crucial for efficient communication between different brain regions. Imagine it like an orchestra, right? Each instrument playing its part in harmony to create a beautiful symphony. Gamma oscillations are like the conductor, making sure everything works together smoothly. Without them, the music would be chaotic and dissonant, much like a brain without properly functioning gamma oscillations. Now, in Alzheimer's disease, these gamma oscillations are disrupted. Studies have shown a reduction in gamma activity in Alzheimer's patients, and this disruption is thought to contribute to the cognitive decline seen in the disease.
Wow, that's totally fascinating. So how does this DDL920 molecule fit into all of this? What did Dr. Modi's research actually show?
Well, Dr. Modi and his team, they found that DDL920 can actually enhance these gamma oscillations. It targets specific receptors on certain brain cells called parvalbumin interneurons, and by blocking these receptors, the drug actually boosts the power of these gamma oscillations. Now, to test this in a model of Alzheimer's, they used mice genetically modified to mimic many aspects of the disease, including those cognitive and memory problems. These mice were put through a test called the Barnes maze. Imagine a big round table with lots of holes around the edge. One of these holes has an escape box underneath where the mouse can hide. There are visual cues on the walls to help the mice find their way. The mice are given time to learn where the escape box is. Then the box is removed and the mice are tested to see if they remember where the hole was.
Oh, that sounds like a pretty clever way to test their memory. So how did the mice do?
So the Alzheimer's mice, they really struggled without the DDL920. They were essentially lost. They couldn't remember where the escape hole was, even after they'd been trained. But the mice treated with DDL920, they performed much better. They found the hole more quickly, spent more time in the right quadrant of the maze, and their path to the hole was shorter, much like the healthy wild-type mice. It was a remarkable improvement, really, suggesting that boosting gamma oscillations with DDL920 could potentially restore cognitive function.
Okay, so this DDL920 sounds really promising, but how far off are we from actually using it in humans? What are the next steps?
Well, Anna, it's a long road from mice to men, as they say. First, they have to do a lot of toxicity testing to ensure that the drug is safe at higher doses in different animal models. They need to find the right therapeutic dose without causing any harmful side effects. Once they've established a safety profile, they can move on to early human trials.
Right. So what would those human trials look like?
Well, they'd likely start with healthy volunteers. Give them the drug and monitor their brain waves using an EEG to see if it's actually boosting those gamma oscillations like they expect. If that's successful and if the drug seems safe, they could then move on to patients, maybe people with mild cognitive impairment or early stage Alzheimer's. Ideally, the goal is to catch the disease early and maybe even slow or halt its progression.
Wow, that'd be incredible. So, are there like any other potential uses for DDL 920 beyond Alzheimer's?
Well, interestingly, gamma oscillations are also disrupted in other neurological and psychiatric conditions like schizophrenia, depression, and even autism spectrum disorders. So, if DDL 920 proves to be safe and effective for Alzheimer's, it could potentially be explored as a treatment for these conditions as well. The possibilities are pretty exciting.
Totally. This could be like a game changer for so many people. So what are the biggest challenges, facing the development of DDL 920 for humans?
Well, the extensive safety testing is critical. They need to make absolutely sure it's safe and well tolerated in humans. And, of course, securing funding for these trials is always a challenge. Drug development is a really long and expensive process. But given the potential benefits, it's certainly worth pursuing. The more we learn about gamma oscillations and their role in cognitive function, the better equipped we'll be to develop new and effective treatments for these devastating diseases.
So Dr. Reddy, like assuming everything goes well with the trials and DDL 920 becomes available, when would it ideally be given to patients? Like at what stage of Alzheimer's?
Well, ideally, in the early stages, like mild cognitive impairment or the very first stages of Alzheimer's. The hope would be to delay or even halt the progression of the disease. It might even be used in combination with those existing antibody treatments that clear out amyloid plaques.
Oh, that's like really interesting. So it could work alongside those other treatments?
Yes, clearing the plaques is important, but it doesn't necessarily restore lost cognitive function. DDL 920 could potentially help with that.
Got it. So, how many treatments might a patient need? And are there like any other health conditions that might, prevent someone from taking DDL 920?
It's too early to say for sure. A lot will depend on those safety and efficacy trials, but they'll need to figure out the optimal dosage and frequency. As for other conditions, well, certain comorbidities might rule it out. That's something they'll have to carefully consider during the clinical trials. They'll need to see if there are any drug interactions or other factors that could make DDL 920 unsafe for certain individuals.
Right. And given how prevalent Alzheimer's is, like what are the broader implications of this research for patients, their families, and society as a whole?
Well, Alzheimer's places a tremendous burden on caregivers and the healthcare system. A treatment that could effectively slow or halt the disease's progression would be absolutely transformative, not just for patients, but also for their loved ones. It could dramatically improve quality of life, reduce healthcare costs, and have a significant positive impact on society as a whole. It's truly inspiring research.
Wow, Dr. Reddy, this has been absolutely fascinating. Learning about DDL 920 and its potential impact on Alzheimer's has been totally mind-blowing. So to wrap things up, could you summarize the key takeaways for our listeners?
Absolutely, Anna. So the main point is that gamma oscillations, these high-frequency brain waves, are essential for memory and cognitive function. And in Alzheimer's, these oscillations are disrupted. The DDL 920 molecule seems to restore these gamma oscillations in mice, leading to improvements in cognitive performance. And the really exciting part is the potential for human applications, possibly even slowing or halting the progression of Alzheimer's.
Right. And it's so important to remember that this research is still in its early stages, but the initial findings are incredibly promising.
Exactly. And there's still much work to be done, like rigorous safety testing and clinical trials. But the hope is that DDL 920 could one day offer a new treatment option for people with Alzheimer's and potentially other neurological and psychiatric conditions too.
Wow. So, listeners, we really hope you enjoyed today's episode of Everyday Health Stories. A huge thank you to Dr. Kota Reddy for sharing his expertise and insights.
My pleasure, Anna. It was a great discussion.
And before we go, a quick reminder to our amazing listeners to subscribe to the podcast so you don't miss any of our future episodes.
Certainly. And one last thing. Please remember that this podcast is for informational purposes only and does not substitute for professional medical advice. Always consult your healthcare provider for any medical concerns.
Until next time, stay healthy, stay curious, and keep listening to our podcast. Remember, every story has the power to transform lives. Bye for now.